In this paper, we introduce ColabAR, a toolkit that uses physical proxies to manipulate virtual objects in Tangible Augmented Reality (TAR) laboratories. ColabAR introduces haptic-based, customized interaction techniques to promote remote collaboration between students. Each module contains an AR marker, an Arduino Nano 33 BLE Sense with a built-in IMU, a linear haptic module, and a battery. Each module has a small dimension of 48 by 23.5 by 13 millimeters, which allows it to attach with glue or Velcro to most of the daily objects. Our toolkit uses VLE protocol, which connects modules to smartphones. This protocol needs a significantly low power consumption, which ensures sufficient battery life for most STEM labs, about 2 hours. Using our Unity package, content designers can easily customize and create different haptic module behaviors and integrate them into an existing AR application. Our package comes with prefabs of our AR tags, which designers can select and choose from our 3 types of feedback. Physical reality simulation provides the perception as if physical properties and constraints still persist when interacting with virtual objects. Our 7 built-in patterns are collide, dock, switch, knob, electric current, chemical reaction, and liquid flow. Notification feedback provides users with awareness of hints and cues from the virtual world. Our 4 built-in patterns are ding-dong, beep, interval, non-stop. We divide this feedback into 2 categories: system feedback, which is predefined by the instructor, and partner feedback, which can be used by students to signal to their partners. Freestyle feedback, freely customizable by the designer. They can create up to 5 different haptic patterns in sequence. Each comes with 3 variables for adjustment: frequency, amplitude, and duration. Modules, phones, and a remote server form a multi-tier network architecture. On the lower tier, modules are linked to the phone through the Bluetooth Low Energy BLE network. On the upper tier, the smartphones from different users are connected to each other through an intermediate server. The TCP/IP protocol is used in this tier to ensure reliable data transmission between phones. Organic Chemistry Laboratory, purification of solids by recrystallization. Students worked remotely in pairs with their respective tangibles. For example, they used daily objects such as a cup, a spoon, an Apple Pencil to serve as a beaker, a lap spoon, and a stirring rod. The haptic feedback made the process smoother and immersive. Pouring the water, scooping, stirring, evaporating of elements, there is dynamic haptic feedback. Spatial tactile feedback can reduce the overload of information in the visual and audio space. Vibration is actuated by one user to inform his or her partner. In our case, vibration conveys the message of tool selection, which is used by a student to guide his or her partner to the correct object. The length of the vibration is chosen by user's preference. One collaboration task description. Participant 1 places the evaporation disc under the funnel, and Participant 2 pours the solution from the beaker into the evaporation disc through the funnel. Participant 1 places the evaporation disc on the burner, and Participant 2 stirs the solution in the evaporation disc. Lab description. DC circuits, connections in series and parallel. The tangibles used represented LEDs and multimeters. Our laboratory showed comparable performance results between ColabAR and a Zoom lab that used the actual physical components. Our laboratory decreased completion time for an average of 25%. Some exploratory use cases. Machine design TAR laboratory for a combustion engine evaluation class. Physics TAR laboratory for a reflection, refraction, and dispersion of light class. Art TAR laboratory for a basic sculpting class.